She drives by with her
So
boyfriend.
Jennifer, did you understand the stuff?
Yes and no. I keep getting confused on when we need to do it with, we divide and then we do the square root.
Right.
So what I did was I went through all the videos again. That's what I was doing before I got on and made some notes. So I think I'm catching on, but it's just, yeah, it's a little tricky.
Yeah, I was telling Linda I have an appointment with a tutor on Monday.
And I called my daughter, and last night she watched lesson 7, the video. And when I talked to her this morning, she said, "Holy cow, Mom, I don't know how you're doing this online," because she said he went so fast. There's no way I even understood what he was saying. And she said he was good, but he went really fast. So her suggestion was watch the video or read through the stuff and watch the video at the first of the lesson, go through the homework and stuff, and then watch him again, because then he should make a little bit more sense.
And that's exactly what I did, and I do think that made a difference.
Good.
So now I'm going back to the other lessons to kind of review for the test and watching those videos again. And I don't know. We'll see how it goes.
Yeah. Well, let's go ahead and get started since Linda's got to go. So I'm looking at this one because I opened up the quiz, so I started kind of working on it.
Uh-huh.
So the first one, the answer I got was 0.175.
Let me find my. Yes.
Okay.
0.75.
But it's no. It says to
0.175.
3 decimal places. So it's 1.1745.
Oh, 7. Yeah. Oh, yeah. Sorry.
Because we have to do it to 4 decimal places.
0.1745.
Yeah, because I was rounding it to 3.
So it's just finding the z-score and putting it in the applet.
So, because this says round your answer to 3 decimal places. So should it be 0.175 or 0.1745?
1745, because it's 3 decimal places.
Yeah, so it should be 175.
Well, I put 0.1745 and I got it right. So
okay,
but it probably should be 175.
And the next one, I didn't think which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population. I didn't think there was enough information given to be determined, but
it's the distribution of the sample means.
Okay.
So if you think about it, because I asked my daughter to explain this one, which of the following will have a smaller standard deviation? So they're going to be closer together if 9 observations are randomly drawn from a population.
Oh, okay.
So.
Wait, what number are you on? Are you on 2?
4.
Oh, this is the homework quiz. Crap, that's the wrong one.
I did that once. It'll let you close it. It will just make you go back into it to finish it.
Oh, crap. I'm like, what the heck are you doing? Okay. So I don't have to submit it. I can just get out of it?
Yeah. I did that once.
Don't do anything. Just go to something else and it'll save it.
Yeah, just click on content and then click on group quiz. I did that once too.
Okie dokie then. All right. So sorry about that.
Nope, I totally did that once. So it's like, no, I didn't want to open that. Luckily, it's not like an exam where once you open it, you're up a creek.
I know. Okay.
So the number 4, if you think about it, if you have which of the following will have the smaller standard deviation if 9 observations are randomly drawn? So it wouldn't be the distribution of individual observations. It's going to be your sample observations that would be smaller, because they're going to most likely be closer together. I don't know if that makes sense.
No, that
makes sense. It doesn't in my head.
And then
So
Which
for,
of the following results
okay, so
implies
for
that this,
4,
Oh,
I'm
go ahead.
sorry.
4
Oh,
is
number
the
4 is-
distribution of the sample means.
the middle
Okay.
one.
Okay.
So then 5,
Sorry.
which of the following results implies that the spread in the sample mean decreases on the sample as the sample size increases?
And
So
I
remember
thought that
this-
was the normal distribution.
It's not that. Remember the central limit theorem talks about the shape,
Oh, yes,
and the
that's
law of
right.
large numbers talks about if the size increases, then
So- So it's the law of large numbers.
yeah.
That makes sense. That totally makes sense, actually.
Because it's talking
Makes
about the
sense.
spread, and that's the law.
And that's as far as I got with like pre-doing stuff, but obviously I got 2 at those wrong. So
That's okay. So the next stuff 4 questions we go off of. Scores on the quantitative portion of the GRE are approximately distributed with the mean of 150.8 and the standard deviation of 8.8. So the first thing it wants to know, Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score?
So this is the
So you just
basic,
do-
find the basic Z-score, right?
Right.
yeah, so
the
we have to
160
subtract 160 minus 150.8, right?
Yes.
Right,
Oh,
then
then it's
divided by
over-
8.8.
It's
mhm.
it's over.
The standard
8.8.
deviation.
And is there a square root underneath that 8.8 at all? Okay.
No, because there's no sample, and that's what I was.
So sample. That's okay.
So we just do the regular Z-score. So when there's a sample, that's where I was like, huh, how do I know? So now I'm starting to catch on.
Yeah. Okay.
And what it really boils down to, and I said this to my daughter, I said, I just need to know the terminology so I know what numbers they're asking for.
Exactly.
And she said, that's what you need to know, is because it's just all statistics is just plugging in numbers. So if you
So-
know the terminology, you'll do fine.
Is that 1.045?
Yes.
Oh my gosh. And that's how I write it out, right?
Uh-huh.
1.0. I got it right. Oh my gosh, you guys, I got it right.
Good job.
I even knew the equation. I even knew the equation.
Okay.
7,
so
what is the
now-
probability? Go ahead.
No, now we do our little square root thing.
Right. So what is the probability that a randomly selected student will score above 160 on the quantitative portion? So
So how do
now,
we write out this equation?
So first we have to find the Z-score, right? So it would be, okay, this is where I get a little confused on what numbers we're supposed to put in.
oh, I wish I would.
So we're looking for above 160. So that means that it's 160 minus the mean, which is 150.8 divided by
The standard deviation.
which is 8.8, and the square root divided by the square root of one.
Of what? That's what I'm trying to do.
Of
Where is it? Of 30 is my sample. Is there a sample in here?
There's not. I didn't see one.
So then, okay, so
how did I do this one? I'm trying to look back
So
at my
then- yeah.
spreadsheet thing and see how I did it.
Okay, no, wait. So I did this, but no, I'm sorry, I'm wrong. So it's not divided by the square, it's just divided by the deviation.
Which is
Right.
8.8.
Yeah,
Isn't that the same thing we did for number 6 though?
it is. But then we have to go to the applet and plug in that Z-score and shade everything to the,
Because it says probability.
Above.
I think anything time it says probability, you need to go to the applet to
applet.
see what this probability is.
Okay, so when we
Then we
do
shade everything to the which side?
to the greater than, because it's above, so to the right.
And so it's
So
0.148,
Correct.
correct?
by 8.8 is, so the z-score is 1.045. Oh, we already got
Yes.
that. Sorry.
That's okay. I know, because you don't realize that
Yeah.
you can go back and use that number from before.
And it's, so the area is 0.148.
Because you're doing the area.
I am actually understanding this.
0.148.
Yep.
I'm trying to pull the applet up, sorry. I'm a little behind you.
That's okay. So that shows that what the probability of the score being above 160 is. Because I would read that and I'm like, before I would think, where am I supposed to find that 160 in this applet or the chart or something? But it's in your problem that you take, and then you take the answer to that to the applet.
Got it. Oh my gosh, I can't believe I'm getting this. I'm starting to get it.
See, that's why I think you read the information, but you don't really know if you understand it until you do some of their questions, and then it's like, oh, okay, this makes sense. So are you ready for 8, Jennifer?
Hold on. So wait, I'm just making sure. Okay. 0.148. Okay, yeah, I'm ready.
Okay. So 8, a random sample of 5 students was selected to take the GRE, and it gives us their scores. What is the z-score corresponding to the sample mean of these students?
And this is a question like I totally got wrong in last week's homework test.
Well, I added these together and divided by 5. Well, and my daughter said, Mom, you already know the mean is 160, which it comes out to 160 for them as well. So I'm just trying to figure out what I did. I think just the regular 160 minus, no, I didn't, that wasn't it.
Are these the same? Okay, so is this question go with the data from question 7?
Yes.
See, that's what throws me off is I'm reading these questions and I'm trying to I guess I was confused how they're all related. So then this would be your random.
Says well, if you look at it, it says use the following information to answer the next 4 questions.
Yeah, yeah.
But I missed that too in the very beginning.
So
Okay,
we
so
need to
then
find the z-score for
the random sample.
Right, so we have to do the longer version because it's talking about a sample.
So we know it's the 160 minus 150.8 over 8.8 to the square root of 5, over the square root of 5, right?
Right.
I think so. Mm-hmm.
Oh my gosh, I'm just like.
You're getting it.
I may be able to cancel my tutoring
I was ready
appointment.
to drop the class because I just thought I can't keep up. This is going, so fast. But after I did this quiz this morning, I was like, oh, maybe I can get it. So I'll let you guys compute that and see what you come up with.
I don't know if my calculator did that right.
Did you get 2.34 something?
No, not even close. I think my computer didn't, my calculator didn't put in the equation right. So what was it, 2 point?
Well, I didn't keep going with all the numbers. I got 2.34096, 2.3409.
We only have to go a couple of them.
Yeah, so I just.
So the answer is 2.338. I think the important thing is that you don't shorten any of your numbers.
I know.
Put in at least 5 or 6 decimal point after the decimal point. Put in at least 5 or 6 until you get to the end, and then round it to your 3.
Even if there's like a million zeros? 1,
You
2,
wouldn't think so.
5, 3, 4, 5 zeros. Okay. And then 8.8 divided by 5 to the square root is 3.935480. 1, 2, 3, 4, 5. $2.337707 or 2.3. Yeah,
3.8.
so it 2.338.
Yeah, 2.337707.
Yeah, so you have to put all those zeros in. But is that
Yeah.
the Z? That's the Z score. So we don't have to go to the applet for this one.
Right, that's it. That's the answer. 2.338.
When I tried to calculate it all together as like one big formula, it came out with something really weird. But when I broke it down, it came out.
You have to break it down. Yeah.
And that's where I've been like dropping numbers, and I think that's where I'm getting off.
Because it just changes it a little bit, but it changes your answer to the wrong one.
Exactly.
So then this is where we'll go use the applet. We'll put in that Z score.
No, we don't need to.
No, that was the answer. Oh,
No,
on
for
number 9. Yeah.
Oh.
Do we
So what
put
is the probability that the 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
So do we put 2.388?
In
338.
the bottom. And then we go greater than, so it should be 2.338.
Yes.
And we just shade to the right, correct?
Yeah.
So it's like 0.0097.
Correct.
What? Oh, sorry, my bad. I was looking in the wrong spot.
I actually think I know how to figure out a Z-score. I haven't been able to figure it out.
And then it's just knowing when to use that simpler equation or if you have to add in the square root of.
Well, how you know is that square root is a sample. So if you have a sample, you have to use the square root.
And if it says probability, you use the applet. So for the next 5 questions, we use this information. So for the rest of the quiz. And I thought it was rude that they had 15 questions instead of 12. What is the shape? Okay, so the info is, suppose the mean of BYU students is GPA is 3.5. So that's the mean. And the standard deviation is 0.7. It's well known that this distribution is left skewed. A random sample of 81 students will be drawn. So what is the shape of the sampling distribution of the random variable, the mean of the sample, which represents the sample mean of 81 students who were selected? That was left skewed. So what do you think this one's going to be with a sample of 81?
Well, this one will probably be right skewed, won't it?
If it has a sample bigger than 30, it's going to be normal. If it was less than 30, then it would stay left skewed.
Where are you getting 30 from? Is that just?
Oh, that number was in a couple of lessons ago. If you have a sample that's 30 or greater, then you can pretty much determine that it's going to be approximately normal.
Oh, I missed that. Okay.
Do you remember that, Kelsey?
No.
Yeah.
The 30 or
Yeah,
above.
now that you're saying it, I remember that.
So then this would be approximately normal for number 10.
Yep.
Correct. Right.
Okay, what is the mean of the distribution of the sample means? I thought these words. Sampling distribution for all possible samples of size 81 that could be drawn from the parent population. I hate word problems.
So then you have to break it down and figure out what they're saying. So
Yeah.
they want the mean of the distribution of the sample means. So the sample distribution, so we're going to be using that bigger equation. For all possible samples of size 81 that can be drawn from the personal population. But
isn't this just the mean of the mean? We don't care. It doesn't matter what the sample size is because we
Or what
use
is the mean of the distribution?
The mean is
And how do you figure this one out? What kind of,
3.5.
Right, and what did
Because
you use to get that?
okay, so when we go on and do all of these equations and we try to find out the mean is always
Well,
the same.
yeah, because the mean GPA is 3.5.
Mm-hmm. So it doesn't matter what our population sample is.
Oh, right.
So then our answer should be the 3.5.
Right, and that throws me off too. See?
Did you get that one right or not?
Yeah, I did.
Okay,
It's
so it's
3.5.
3.5? Okay.
Yeah.
And so basically I don't even look, I just look at the mean and because it's always the same.
Mm-hmm.
It's just the deviation is what you have to square root.
Okay.
That's what changes when you have a population sample.
And so then they want to know, what is the standard deviation of the distribution of the sample means for all possible example sizes?
So that's where we need to do our square root.
And so how would we write this out though? That's what I'm like, what numbers go where?
To find the standard deviation of the sample mean, you just do
The square root of the standard deviation.
Which is
Square
root of 0.7.
Uh-huh.
You do the standard deviation of divided by the square root of 81.
Okay.
Is that right?
16 over 30. So hold on. I'm looking at something else. The standard deviation divided by the square root of the sample size is going to give us our standard deviation.
Right.
So it would be 0.7 divided by the square root of 81. Is that what you
Right.
just said? Sorry.
Yeah.
And that's
that's fine.
Is that 0.007?
I haven't done the math.
No.
0.7 divided by,
Oh, I was doing 0.07, sorry.
it's 0.077778.
Yeah, 0.0777. Yeah. Sorry. I was putting an
So
extra
3 decimal places would be 0.078.
Mm-hmm.
And what I found too is I got the last 2 wrong, so I called my daughter back and I was talking through them. I don't think she said 2 words. I figured them out, but I just needed her to listen to me figuring them out. So
Sometimes
this
that
is
helps.
when we go to the applet. What is the probability that the mean GPA for 81 randomly selected would be less than 3.3?
But we don't know the z-score yet, do we?
no, and so we need to
Figure that out first.
Yeah. So it's the long equation.
And so, what is the top? Is it that's why I'm getting lost. Is it 3.3 minus 3.5?
Yes.
So it 3.3 minus
Is your variable minus the mean
3.5 divided by
the standard deviation.
0.7.
0.7 divided by the square root of
The sample size 81.
81.
You guys were getting this.
I don't know how I'm going to take a test next week, but
I know. I think our 1 page of notes will save us.
One, two, three, four, five. Hold on, Emily.
I have an Emily too.
Is that 2.57? 1?
Yes.
Oh my gosh, can't believe I got that.
2.571.
Yep.
And then that
And so
goes in the app, right?
and then we go to the app.
2.571.
And it wants to know what's less than the 3.3.
So we go to the left-hand side, and it is 0.0051.
Yep. And you round it to 3.
So it would be 0.00, no,
Five.
0.01.
No.
No.
You round it
Okay,
to
okay.
3.
Hold on, my tablet keeps resetting itself. 2 point what? 571?
Uh-huh.
Yes.
And then we're just, so where are we shading?
To the left.
Just the little one at the left.
So it's
Yep.
0.0051.
Yep.
Correct.
And then
So
we'll
you-
put in 0.005.
Right. Now, this next one I got messed up on, and I don't know if I got to the right answer or not. It wants to know what the possibility that 81 students would be greater than 3.3.
So is it the same information, but we just shade to the right?
So it would it be the whole middle and the little part?
No, because the z-score is the same, correct?
Yeah.
So we don't want anything in the middle. We only want it greater. So then it would actually be the same answer.
And that's
0.005.
wrong.
Mhm.
And that's wrong.
Is that wrong?
That's wrong.
Then
So
That's
how did
why-
you figure that one out, Linda?
Well, I don't know if it's right because I haven't gone back and done the quiz the second time. When I called my daughter, and she thought it was weird, the high number, but what I came out with was 0.97. Let's see.
0.9949.
Where did I write that down wrong? Because you'd have to, if it's everything above the 3.3, you'd have to do the middle and the top.
Yes.
no. But why are you doing the middle and the top? Because it's greater than the z-score. Oh, because the middle, yeah, you're right. Because we're starting at the lowest point and going forward, right?
Yeah, so
That's the only thing I
0.995.
could figure.
Yeah. 0.995.
0.995.
Is the test multiple choice?
I hope so.
Because that will help. Well, I
Probably
mean,
not. Let's see. The United States assumes the mean weight of passengers. So I know 185 pounds is the mean.
I think it's good to write that stuff down as you go.
Previous, yeah.
yeah.
Lower, raised after. Weights are random. So the sample is 48.
Mm-hmm.
That's all I'm writing down, like I'm labeling what the sample mean was determined to be.
177, and the standard deviation is the 26.7.
Mm-hmm. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean.
Did you get this one right, Linda?
No.
Darn it. Okay, so I see a problem here, and I don't know. I don't know if we've ever had this before. So if you read the first sentence, Coast Guard assumes the mean weight of passengers is 185. But then it also talks about the sample
I'll be
mean,
right back.
okay,
Okay.
was determined to be 177.6 pounds. So there's two different mean weights in here. Do you see that? So which one are we supposed to use? The sample mean of the, you know what I mean?
There's a sample mean and there's a population mean.
But I've never had two means in there. Have we? Or am I just confused?
Probably not.
That's
Sorry.
why
I'm back. It was a work call.
Okay, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than observed in this sample.
As extreme or more extreme means
Oh,
lower than the ones we observe, but also values that are far away from the means as ours is the positive direction. This is an interesting problem.
Yeah.
so what I'm thinking that they're wanting to know is this sample mean was determined to be 177.6. I don't think we need to use that because I think it's asking us to find the probability that a random sample of the passengers, which the passengers mean is
Right.
185 pounds, will have a weight as extreme as a 177.6 or more extreme. I think that number is there to throw us off, but I could be wrong.
But it wants to know if it's as extreme or more extreme than the sample mean.
So then we don't use the other mean then, right? The 185? We use the sample mean?
Let me look
Yeah, I don't know.
Would we use the 177.6 minus the 185?
Well, why would we do that? Oh, I'm just wondering.
I know, because it's asking about that sample mean as compared to the population mean.
Okay.
So would 177.6 be our variable? The X?
Okay, hold on. I'm going back here.
I'm going to try that.
See, that's where I get confused. Some of the
I
ways
got-
we word it.
I got, for all of that, if we do the 177.6 minus 185 over 26.7 over square root of 48, I got a z-score of 1.920176, which would really be just like 1.920.
Mine's a negative. Was yours a negative?
Yes.
Okay. So negative 1.92. And then it says underneath it, it says, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also the values that are as far away from the mean as ours in the positive direction. So I think it would be the two corners of the output.
And that would be 0.0549.
Right. And
Is that
that's
what
the
you
one
originally put?
No. I think I just took the bottom one to begin with. But it's the extreme both ways it's asking for.
I'll put it in, and that, you want me to submit and see if we're right?
Yeah. Because we should be right on 1 through 13, and then 14 and 15 would be our questions.
Yep. We got 14 and 15 right.
Oh, we did? Okay,
I
cool.
actually did that problem.
Okay, so what you did, the 177.6 minus 185
The 170.
divided by the deviation.
26.7 over the square root of 48. And that gave us a z-score of 1.920.
Mm-hmm.
And then you put that in the probability app, and you just highlight the two ends.
Yep.
Which gives you the area of 0.0549.
The extremes.
Okay.
Oh my gosh, you guys, I actually understood the math we were doing.
Awesome.
You guys
did
are
it,
awesome.
ladies.
Thank you.
Well, we survived. I will submit the broadcast.
Awesome. Thank you.
Have a good weekend.
You too. Bye.